Hey folks, today's topic is the equation of lines. This should be probably the most straightforward notes that we get to take all year. So just a couple things to remember about a line. A line is a straight line. A line is considered a line when it has a constant slope. So like a parabola is not considered a straight line because it doesn't have a constant slope. So a couple, remember Parallel lines have the same slope, rise over run, some things that we think about when we think of lines. But anyway, okay, so in calculus, we'll be writing equations of lines: tangent lines, normal lines, horizontal lines, vertical lines, straight lines, pickup lines. That's a new one. Let's highlight a couple of these and just remember what tangent lines mean, or equations. I'll focus on these two, I guess. Horizontal lines are lines that go left to right. So if I were making a sketch, this would be a horizontal line. Now, what is the equation for any horizontal line? Well, which axis did this hit and which axis did this not hit? This only hit the y-axis. So it has an equation, y equals some number. Versus over here, vertical lines. What does a vertical line look like? Vertical line looks something like this. Which axis does it hit? It only hits the x-axis, so it has an equation, x equals some number. A new phrase is normal, a normal line. That's a line that's perpendicular to a tangent line. We have an example that I'll talk a little bit more about normals. And yeah, so let's get into it. Worth memorizing. Not probably the whole chart. I'll highlight the ones that I think are the most important. Point slope form. So you're given a point and you're given the slope. You're given a point, x1, y1. You're given the slope, m. Notice point form. Well, I'm not going to get into that. Never mind. We also have slope-intercept form. Y equals mx plus b. This is the one that you probably remember the most. This has a y-intercept of 0, comma b. General form, I guess, how about I just put a star next to it? I don't know. We don't usually see general form as often as the other ones. You can't get general form without starting with one of these other forms anyway. So, that one doesn't occur as often. And then Taylor form, I like this one probably the best. Taylor form is just point slope form with the y1 moved to the other side. So, if I were guessing, he underlined these because he felt these were the most important. Point slope is just Taylor form rearranged. So he, in his mind, I'm sure he thought, well, these two are the exact same setup. So why memorize both of them? Anyway, whichever one you like better, you can use as your go-to equation. For any lines, the only thing you'll ever need is point slope form. That's the one we'll use the most, and then I alter it to look like Taylor form. Now here's the biggie. Remember, there are only two things you need when it comes to coming up with the equation of a line. You need a point and the slope. That's it. That's it. Anytime you want to come up with the equation for a line, you need the point, you need a slope. A couple of things that are worth remembering. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slope. And then normal lines are perpendicular. I guess I'll go back to yellow. Normal lines perpendicular to a given line, or orthogonal is a phrase that you might see in physics class. So just as a quick reminder, I'm going to give you an example of a slope. Let's say slope is 2/3. The parallel slope, m parallel, would be 2/3. The perpendicular slope would be negative 3 over 2. So notice it's parallel slopes, exact parallel lines have the same slope. Perpendicular have two things, opposite and reciprocal. So I took this number, it was 2/3, I made it negative. And I took the fraction 2/3, it was positive, I made it negative. I took the fraction 2/3 and I reciprocaled it to 3 over 2. So let's get into it. Write an equation of a line passing through the point 2, -3 with a slope of 3/4. Write your answer in Taylor form, slope-intercept form, and general form. So if we want to write the equation of a line, what do we need? We need a point and the slope. Every single time. Do we have that? Yep, we have the point. We have the slope. So we're good to go. So part A, they want it in Taylor form. So Taylor form is slope-intercept form with the y1 bump to the other side. So it would be y equals y1, that's our y1, would be -3, plus our slope is 3/4, times the quantity x minus x1. So look at what's happening here. Whatever your x is, the sign is going to change because there's a subtract in front of it. So this would be -2. Part B, write an equation in slope-intercept form. Now you can go right into slope-intercept form. So you would start off with y equals mx plus b. Y equals, do we know what m is? Yes, we do. Our slope is 3/4. X plus, do we know what our y-intercept is? No. So this is what we've got to figure out. We've got to figure out what this y value is, this y-intercept value is. But to do that, they have to have told me x and y, which they did tell us x and y when they gave us that point. So our point is -3 equals 3/4 is already in there. Our x value of 2 plus b. Now we start to clean this thing up. -3 equals, what's that going to be? 6 over 4. No, yeah, 6 over 4, which is going to become 3 over 2. Plus b. Who's keeping b from being by himself? The 3/2. So I'm going to subtract 3/2 from both sides. I'm lazy. When I try to do a common denominator, I don't want to rewrite the whole thing just to fix this. So I usually just kind of cross it off, and -3 needs a denominator of 2, so that would become -6 over 2. So -6 over 2 minus 3 over 2 is -9 over 2. So then my equation would be y equals, slope was 3/4, x plus b, in this case, which would be subtract. I don't like the way I wrote that up there. Then write your equation in general form. This is what I was talking about when we were up here. General form, I don't like it as much because you can never get directly into general form. You have to go with one of these other forms and then algebraically manipulate it until you get it into general form. So I'm going to take this slope-intercept form and I'm going to work on that one. So we would have something like, what would be a good color here? Maybe a light blue. I'm just going to use this to start me off. All right, so if I want general form, a couple of things have to be true. First of all, there can be no fractions. Notice this says integers. They must be integers, which means they can't be fractions. And generally, you don't want this term to be the negative term. If this ever turns out to be a negative, we usually just multiply through by a negative to get rid of it. So let's see. Okay, I'm going to kill off the fractions first. So let's rewrite it. I'll show a little bit more of my work than I normally will do after this. I'm going to take this thing, I'm going to multiply it. What could I multiply this by that would kill off all those fractions in one move? 8 would work, but then I'd have to reduce it at the end. I'm going to use the least common multiple of 4. So remember, you're going to multiply this to everything. So 4 times y is 4y equals. So there's two ways to multiply a 4 times the fraction. One way is to multiply the top and then divide by the bottom. The other way is to divide first and then multiply. Generally, that's the better way to do it, especially when you pick a number that was divisible by the denominator. So what's 4 divided by 4 is 1. 1 times 3 is 3. Then I'm going to distribute this again. What's 4 divided by 2 is 2. Times negative 9 is negative 18. Okay, so there we go. No fractions. Life is good, but x and y need to be on the same side for general form. So now I'm going to bump the 3y to the other side by subtraction. Sorry, 3x equals negative 18. And like I said, I would probably give you full credit for this, but this would never be a multiple choice answer on an AP test or on a test in class because this negative is out front. So what we would do now is divide both sides by a negative. Or multiply both sides by a negative, I suppose. I guess I said divide. It doesn't have to. I mean, they're the same thing. So, all right. So there's our kind of a reminder, refresher on all of our different forms. Write an equation of the line that passes through the points negative 5, 1, and 3, negative 7. So right away, I'm going to highlight this. Equation of the line. This is something that you must memorize. You should know by heart. What do we need for this? We need a point and the slope. Okay, so we've got points. We've got 2 points, so we can pick either one of those. Now we need the slope. Do you remember the slope formula? Delta y over delta x, y2 minus y1 over x2 minus x1, however you want to remember it. Rise over run. Which one of our, in the coordinate plane, who does the rising? Y rises while x runs, which is exactly the way that our slope formula is set up. So anyway, plug and chug from here. My slope equals y2 minus y1 over x2. Ooh, minus a negative means plus, right? That's where that plus came from because I'm subtracting a negative. Negative 7 minus 1 is negative 8. 3 plus 5 is 8. Negative 8 over 8 is negative 1. So now I have the slope. Now I have a point, and it doesn't matter which one. Write the equation. I like Taylor form, so I'm going to write mine in Taylor form. So y equals y plus the slope, but our slope was negative 1, minus x minus, there's one possible answer. Now, a lot of kids would want to say that 1 minus 1 is 0, so this would be no. This is connected by multiply, so we can't subtract until we multiply. The other way you could do this, you could also have done this using slope-intercept form. Nah, not slope. I don't want to go into slope. I could have. I don't want to. What would it look like in point-slope form? Y minus y equals slope times x minus x. There's another okay form. And then we could have done all of this with the other point. So that was with this point. We could have also done this using this point. All right, where did we leave off? Oh, yeah. So I could have also written this. Let's say I wanted to write it in Taylor form, but from this perspective. So it would be y equals negative 7 minus the quantity x minus 3. That would have been fine. Or I could have written this in point slope. Y plus 7 equals negative 1 x minus 3. Anyway, there's lots and lots of different ways to do this. If you wanted to write it in y equals mx plus b, feel free. I'm not going to go that route. All right, so write the equation of the line. I'm going to stop right there, and you're going to want to get in this habit too. When you see important things like equation of the line, write yourself, what does that mean? It means I need the slope and the point. I need a point from the line, and I need the slope of the line. Write the equation of the line passing through the point. Okay, that's good news. There's my point. and is parallel, normal to this line, and then find the x-intercept of the normal. All right, so what can this is what I'm going to be parallel to. Well, if I'm parallel, my parallel slope is equal to whatever my slope is. So I'm going to have to do some work here. I've got to figure out what's the slope of this line. So let's focus on that first. I'm going to manipulate this. Which form is the easiest to tell the slope from? Well, hopefully you said y equals mx plus b. I don't like that form. I don't like to write my equations in y equals mx plus b. But if I need the slope, it's much easier to manipulate an equation into y equals mx plus b than to try to manipulate it into one of these strange forms. So I'm going to try to get y by itself. So I'm going to bump over the 2 so I don't have any negatives. I'm going to bump over the 2. I'm going to bump over the 3. So I minus the 3 and I added the 2. Now I'm going to divide by 2. So I would get y equals 5x over 3. 5x minus 3 over 2, which then I can split up. Because these are both over 2, I can break them into their own fractions. 5 halves, 5 over 2 with the x, and then 3 over 2. I don't care about this. People think that this matters. I don't really care. What I really want to know is what's my slope. So my slope is whatever's connected to x once you get in slope-intercept form. Now I can start to analyze this. So from a parallel, I need to know the slope. Well, the parallel slope is the same as the original slope. We know our point is 4, -3. And does it say? No, it doesn't say which form, so I can pick whichever form I want. I'm going to go with slope-intercept, or point slope this time. Y plus 3 equals slope, x minus x. Box it in, put it up on my fridge. All right, normal. What does it mean to be normal? Now, a normal to the line means that the slope of this is the slope. So I want to be perpendicular. So my slope is perpendicular. So now in part B, if I'm going normal, my perpendicular slope would be equal to opposite and reciprocal. My point is still 4, -3. This time I'm going to go Taylor form. So y equals y plus slope, but in this case our slope is negative, times the quantity x minus x. I chose Taylor form because they didn't say what form it had to be. If it was multiple choice, you just look through the answers to see which form they used. And if it's free response, you can pick whatever form you want and go with it. Last but not least, part C, find the x-intercept of the normal line. So part C, what would be a good color here? I guess green. Part C, I need the x-intercept. Folks, pause it if you don't know, if you haven't already written it. What do you know about all x-intercepts? What do their points look like? Okay, hopefully you said x-intercepts all have an x with a 0 for y. So when I'm given an equation and I want to find an x-intercept, I'm going to plug in 0 for y. So let's use, this is my normal equation. 0 equals -3 minus 2/5 times the quantity, x minus 4. And now I'm just going to start messing around with algebra until I get the x by itself. So first of all, I'm going to add the 3. All right, now the farthest thing away from x, I guess I could distribute here. No, I'm going to kill off that -2/5 this time. I don't think I showed you one like this yet. So, well, what I could do, actually, let's do this. Let's distribute and then multiply through. So I am going to distribute. So 3 equals -2/5 x. Negative times a negative is a positive. All right, so you're multiplying a fraction times something that doesn't look like a fraction, so we need to make it into a fraction. 2 times 4 is 8. 5 times 1 is 5. So from here, I'm going to clear these fractions. So what could I times by that would kill off a divide by 5 and a divide by 5? Well, I could times by 5. So I would have 5 times 3 is 15. 5 divided by 5 is 1 times negative 2. 5 divided by 5 is 1 times 8 is 8. Now I'm going to keep moving. Move the 8 over, so that would be 7 equals negative 2x, and then x equals negative 7 over 2. So my x-intercept would be negative 7 over 2, comma 0. I want to show you something from here, another way that you could have finished this, just as an option. Let's go from here. Another thing that you can do to kill off when you have a fraction connected by multiply, I mean, you can divide by negative 2/5. That is legal. But when you divide by a fraction, what do we do anyway? We flip and multiply. So what I'm going to do instead is I'm going to multiply this by negative 5 over 2. I'm going to multiply this by negative 5 over 2. So over here, negative 5 times 3 is negative 15 over 2 times 1. I'm not going to do the 1 this time, but that's over 1. Equals, now look what happens here. A negative times a negative is a positive. 5 times 2 is 10. 2 times 5 is 10. That ends up canceling. 10 over 10 ends up being a positive 1, which then I distribute into the x minus 4. Then I can add 4 to both sides. But I don't want to add 4. I want to add 8 over 2 so that I have a common denominator. Negative 15 plus 8 is negative 7 over 2. And we get to the same place. So either way, I don't really care how you want to do it. I always like to kill off fractions. I just don't like to deal with them. So it maybe creates an extra couple steps, but it's easier. I understand that way better. All right, good luck on the homework.